I want to start today's lesson by going over what I saw was the most missed question on the homework, and that was question number 6. If you got this one right, just skip right through it until you get to the actual lesson, today's lesson. So this is asking us for the area. There are a couple of ways to do this. You could plot the points and then start subtracting away triangles, or the other way is using the shoelace method, which I'll go over that way. So the shoelace method was where you start with 1 point. I'll start with A. And we type it out, -2, -1, then just go down the next point, 1, 3, 3, 4, 5, 0, 3, -2, and then we have to remember to repeat that first point, -2, -1. Okay, then we're just going to multiply these numbers and multiply these numbers, and then add those columns. So if we are to multiply, -1 times 1 is -1, this is 9, 4 times 5 is 20, 0 times 3 is 0, -2 times -2 is 4, -2 times 3 is -6, 4, 0, -10, and -3. Okay, now we're going to go ahead and add our columns. So when we go ahead and add that, we get 32. When we add -6, -10, -3, and 4, we get -15. Okay. And the last step is to take these two numbers, subtract them, and divide by 2. And it's the absolute value of that. So it's the absolute value of 32 minus a -15. And then divided by 2. Okay, when we do that, 32 minus a -15 divided by 2 is 23.5. So the area is 23.5 units squared. And again, that was just the most commonly missed one. Please make sure you're checking your homework under the module. So you should check that before you start the next lesson. In lesson 10-3, we are going to again use trig, but this time we're going to solve for a missing angle. Let's go ahead and we'll kind of skip past this here. Okay, so the keys to solving for a missing angle. This time we need to know two sides. So we need to know at least two sides of the right triangle. Then once again, we're just going to set up our proper trig proportion. We'll use SOHCAHTOA here. And then we'll go ahead and solve. And we're going to use something called inverse trig functions. So here's kind of like what inverse trig functions look like. It's sine just a little to the negative first. That means the inverse of sine, the inverse of cosine, and the inverse of tangent. That will allow us to solve for the angles. And I'll explain that in a moment. So here we have right triangle, CDE, and we want to determine the measure of angle E to the nearest degree. So I'm going to put a variable there. I guess I'll put an x. We're looking at it from the perspective of angle E, which means we can go ahead and start labeling our triangle. Across from the right angle is the hypotenuse. Across is the opposite, and right next to it is the adjacent. We are dealing with the two sides that we have. We have a number on the hypotenuse, we have a number on the adjacent. That means that we are working with the cosine function. Again, remember, if it helps, you can write this out. SOHCAHTOA. In this case, we're dealing with adjacent and hypotenuse. So that's the cosine function. Cosine of some angle is equal to the adjacent over the hypotenuse. That cosine of the angle will give us that ratio. Let's just substitute in what we have. We don't know the angle, so we'll just leave it as cosine of x. We know what the adjacent is, that's 8. We know what the hypotenuse is, that's 11. Now, we're not going to cross multiply here. If I put this over 1 and cross multiply, this is just kind of an aside, don't write this, we would get 11 cosine of x equals 8. That doesn't really help us because it doesn't isolate x. So that's not something we want to do. This is where we're going to use inverse trig. we need to isolate x. So we need to basically get rid of this cosine function. This is a function, cosine, it's giving us this ratio. So to get rid of it, we're gonna do like kind of this inverse. So cosine inverse of all of this. That will eliminate the cosine function. But what we do to one side, we have to do to the other side. So we'd have to then do cosine inverse of this 8/11ths here. Okay, so I'm going to kind of undo all of that. You don't need to write that every time. Basically what you need to do is we're going to do the inverse of both sides. When we do the inverse of both sides, that kind of gets rid of this cosine function. So cosine inverse of 8/11ths is going to give us x. We need to get rid of this cosine function. To do that, we're going to go ahead and do the cosine inverse of both sides. So we need to go over to our calculator. The calculator is going to take care of this for us. To get this inverse, cosine inverse, you hit second cosine, and now we'll just go ahead and put in 8/11ths, and then close it up. So we get 43.34 degrees. Again, we want to make sure you're in degree mode, so if you're not, mode, degree, we looked at that in the last lesson. So that angle, oh boy, I forgot it already, is 43.3. And what are the rounding directions? To the nearest degree. So to the nearest degree, it's just 43 degrees. Looking at the next exercise, we need to solve for angle A. We don't even need to do a variable. Sometimes we'll just look at it from angle A. We'll just call it A. We're looking at it from angle A, so that means 7 is the opposite, 18 is the hypotenuse, this is the adjacent, we don't really care about that. We're dealing with O and H. Real quick, O and H, that's going to be sine. Sine of angle A is equaling the opposite over the hypotenuse. We'll substitute in what we have. We don't have angle A, so I'll leave it as A. The opposite is 7. The hypotenuse is 18. We need to get rid of this sine function. To get rid of the sine function, the inverse of the sine function is sine inverse. So A is going to equal sine inverse of 7/18. We'll go over to our calculator. And basically what the calculator is doing, it's trying to figure out the angle. It's trying to figure out the angle that gives us a ratio of 7/18. So it's kind of thinking, it's doing whatever it needs to do to figure out what that angle is that gives us a ratio of 7/18. And it winds up being 22.88 round to the nearest whole degree. So 23 degrees. Again, we're going to try to solve for angle A. Why don't you pause the video and you try it? Here's the answer to B. We're dealing with opposite and adjacent, so that's tangent. We're solving for an angle. If you're ever solving for an angle, it's always going to be the inverse. When we go ahead and use our calculator, take the inverse, we get approximately 49 degrees. Why don't you pause the video and try this one? And here's the answer to C. I'm going to skip a little bit. We'll skip over D. We'll skip over exercise 3. Let's go to exercise 4. So we have a diagram here. It's showing the path of a bird that flies from the top of a sunflower to a point on the ground. Okay, hold on. We have to get some cool diagrams here. Get a little bird going here. So we got a bird flying to the ground. Okay, so we have a bird flying to the ground, and we need to find the measure of the angle x. Okay. So let's figure out what trig function we're using. We're dealing with opposite and adjacent. So that is tangent. Tan of the angle, which we're going to call x, is equal to opposite over adjacent, which is 9.5. At this point, we're solving for an angle, so it's inverse trig. Tan inverse of 5 over 9.5. Go over to the calculator. Second tan 5 divided by 9.5. And 27.7. 27.7. Okay, round to the nearest tenth. 27.8. Let's take a look at this one. So we have two similar triangles. Okay, we know two things about similar triangles. Their corresponding sides are in proportion, and their angles are congruent. They're telling us that tan of theta, so tan of theta is equal to 3/7, so tan of the angle. So that's giving us a ratio of 3/7. So the opposite is 3, and the adjacent is 7. So let's go ahead and label that. The opposite is 3, the adjacent is 7. Okay. What is the value of x to the nearest tenth? Okay, so let's think about a few things here. Since these triangles are similar, their corresponding angles are congruent, and their corresponding sides are in proportion. So these triangles are similar, which means that if this is theta, then this is also theta. This is the opposite, this is the adjacent. This is the opposite, this is the adjacent. So their corresponding sides would also need to be in proportion. So if their corresponding sides are in proportion, well then let's just set up a proportion. These triangles are similar, their corresponding sides are in proportion. So I could say something like 3 to 2.4, 3 over 2.4 is equal to 7 over x. You could have set up some other similar proportion, but as long as you cross multiply and get 3x equals 7 times 2.4. Let's go ahead and just do 7 times 2.4. Okay, so 16.8. 3x equals 16.8. Divide both sides by 3. Divide both sides by 3. And that should give us, divide by 3, 5.6. So choice 2. So this one wasn't as straightforward. You needed to know a couple of things here. The triangles are similar, so you need to match up their angles and then set up a proportion for their corresponding sides. Okay, so we're going to take a look at two quick things. Angle of elevation. So we have angle of elevation is when you have like an observer on the ground and they're looking up at an object. So their eyes are going, from here, and then they're kind of looking up, and that creates an angle. That's called our angle of elevation. It's always measured from the ground up. Okay, you can think of the angle of elevation in relation to the movement of your eyes. You're looking straight ahead, and you're elevating your eyes and you're looking up at the object. So angle of elevation refers to that angle. Okay, let's take a look at this one. These are some weird looking diagrams. You got some dude parasailing. They're just weird diagrams. Okay, whatever. Getting off track here. We have a man who's parasailing right there. He's above a lake at an angle of elevation of 32 degrees. So here's our angle, 32 degrees. We want to know how many meters above the lake this man is. So we're looking for this. This is a right triangle. We're going to deal with opposite and hypotenuse. So sine of some angle, I'll call theta, is equal to opposite over hypotenuse. Let's substitute in what we have. Okay, this time we have the angle. We're not looking for the angle anymore, so this is what we did last lesson. Sine of 32 is equal to opposite over hypotenuse. Put it over 1, cross multiply. Okay, 129.5 times sine of 32. 129.5 times sine of 32. Hit enter. And we're looking at 68.6. 68.6. Okay, so choice 1. And the last thing today is angle of depression. So this is when you have an observer who's up somewhere high on top of a building on apparently a hot air balloon, and they are looking down at an object. Apparently this guy's looking down at a bowl full of money. Not too sure, but okay, whatever. So you're following his eyes as he looks down at the object. Now, this angle is going to be outside of a triangle, but what we can do is we can go ahead and drop an altitude, and then it becomes, and then we have to just use our properties of parallel lines. So we're going to say this line and this line are parallel. So here's a transversal, which means the angle of depression winds up eventually coming inside of the triangle. So these angles here, this angle of depression, this angle of elevation here, are going to wind up being the same. And then we can go inside of our triangle. Okay, so real quick here, we'll do one more example and then call it a day. We have an airplane pilot. Okay, some guys in here. An airplane pilot can see the top of a traffic control tower at a 20-degree angle of depression. So our angle of depression is really right here. So this is going to be 20 degrees. The straight line distance between the plane and the top of the tower is 5,000 feet. So I guess we could say that this is 5,000 feet here. To the nearest foot, how far above the tower is the plane? So we can draw here, or if you want, you could always do it like this. Kind of make a rectangle out of it. So if this is that's 5,000 up here, well then this is going to be 5,000 over here. If this is 20, because we have parallel lines, then this is 20 degrees. And then it's kind of your call. You could either solve for this height or this height. They're the same thing. It's going to be the same thing. So why don't I just look at this triangle here? Okay, we're looking at it from this 20-degree angle. The unknown side is x. The known side of 5,000 is a. That means we're looking at tangent. Tan of 20 degrees is equal to opposite over adjacent. Put it over 1, cross multiply. We'll go to our calculator, do 5,000 times tan of 20. Okay. So we get 1,819 to the nearest foot. That's going to round up to 1,820 feet. Okay, so you have your assignment. If you have any questions, email me. You have the message board. I'll be looking at my emails all throughout the day. All right, have a good one. Bye.